Good. Very good. Right. I Hi everybody. So one of the things that you get in history of mathematics is that a lot of stuff is miscredited. So there are lots of so and so's theorem that weren't really developed by so and so, that sort of thing. Um, there are lots of reasons that this happens. Sometimes results are lost and then rediscovered somewhere else, and nobody knows about the earlier finding. Sometimes you get this problem that mathematicians don't name results after themselves. So often you get the credit being attached to the better known person who used the concept rather than the person who originated it. That sort of thing happens. But this is a sort of known problem in history of mathematics. And this was played with by this couple of papers in the Mathematical Gazette in 1996. There's this quiz. If you look through the questions, it seems like a very obvious sort of quiz, right? So there's uh, who discovered Cramer's rule, who discovered Horner's method, who discovered, whatever. Um, and then the second paper was the answers. And the point was that the answers tell you that it is not the person who's named. Kramer didn't discover Kramer's rule or whatever it was. And that is the point of the quiz. So I was thinking about generative AI, and I was thinking particularly about how am I going to show to our first year students this problem that, the problem of accuracy. In fact, I'll talk about that first of all. Why does it make inaccuracies? As I say, I wasn't here for the full session, so sorry if you've heard some of this. But what these systems are doing is they're making inferences from the training data. And that means that if there are factual errors in the training data, or if there are biases in the training data, those just get moved through into the model because the model doesn't know any better. It's just using the data that it's given. I quite like this. I saw this in New Scientist last year that they're talking about ChatGPT, and they ask ChatGPT some questions. And in one of these answers, ChatGPT says generative AI models like GPT-3 are designed to generate text based on patterns and examples present in the training data they were trained on. And then it says they do not have an inherent understanding of truth or ethics and are agnostic to the factual accuracy of the information they generate. So that is just a truth. That is just a thing that's true. And you know it's true because the thing that might not always be accurate told you so. Anyway, let's ignore that. But fundamentally, there's this term you might have heard, stochastic parrot. And the idea is that these tools are stitching together bits of linguistic data that it's observed in the training data. According to probabilistic information about, this bit, this sequence of words often goes next to that sequence of words, but there is no reference to any meaning going on in the background here. So this is I'm talking about the sort of raw chatbot, the ones where they're sending off to Wolfram Alpha to do the maths for them or something like that or something else. But in terms of the actual generating text, this is what it's doing. Therefore, they shouldn't be trusted for that sort of thing. However, you get these big claims, right? So ChatGPT, this is ChatGPT's homepage. Get answers, find inspiration, be more productive. It's that first one, get answers. That's how they're selling it, right? So I heard in the previous talk some talk about using it for brainstorming or things like this, or people talk about it for sort of doing some automated stuff for you so that you can be more productive. But the get answers, they're also selling it. In fact, first on the list, get answers. So my methodology, as it were, was to put these questions from this 1996 quiz into ChatGPT and see what the answers came out like. It's a simple test of historical accuracy. These are well known enough in the 1990s to be featured in this quiz. They're not sort of obscure, little known historical inaccuracies. They're sort of big things. I did this middle of last year because I was preparing for my teaching year, and I basically presented what I'm about to present to you to the students at the start of the autumn term. We have a history of maths module in the first year, which I teach. So that was that. So because it was done in the middle of last year, and because I don't pay them any money, it was ChatGPT 3.5 was the system. So First of all, we start out and I say, let's have a quiz. Please answer in one short sentence because I've used it before, this system, and I know that it will write a paragraph. It will write these really long answers if you don't stop it. So I'm trying to contextualize that. It says, okay, I'm ready. I say, who discovered Cramer's rule? Cramer discovered Cramer's rule. Bang, done. Who discovered Gaussian elimination? Oh, no, when was Gaussian elimination first published? I'm using the exact wording from the earlier quiz. Gaussian elimination was first published by Gauss. Thank you very much. And who discovered Horner's method? Horner discovered Horner's method. So this is the paper from, sorry, this is the paper from the Mathematical Gazette. These are the answers from that. So the answer to question one, who discovered Cramer's rule? Colin Maclaren. Maclaurin discovered Cramer's rule. When was Gaussian elimination first published? 1800 years before Gauss. And Horner's method goes back to 13th century China. So these are the facts, I guess. This is what it's missed in answering these questions. So I'll carry on. I might speed up a little bit. How did L'Hopital obtain the rule which bears his name? He bought it from someone. Is the answer. He well, it says here he got it from private correspondence with Bernoulli, and then published it without giving him credit. Anyway, did Pascal discover Pascal's triangle? No. Who solved the Pell equations? Brahmagupta and Fermat. So it's got a lot more nuance here. I do wonder if there's something in the way the questions are phrased, because how did L'Hopital obtain the rule which bears his name is a very different framing from who invented L'Hopital's rule, for example. But anyway, the answer that's given in the Mathematical Gazette for L'Hopital's rule is that he bought it. He bought the rights from Bernoulli as a ghostwriter, which isn't quite what the ChatGPT says. I don't know. I didn't look into the answer. And then, did Pascal discover the Pascal's triangle? It's very hard to say. It was certainly known about earlier. He may have rediscovered it. It's a bit nuanced. And the Pell equations it gives to Lagrange rather than Fermat. I don't know. Again. Really, I was looking for, is it giving the obvious answer? So when was the Pythagorean theorem discovered? Again, it gets that it predates Pythagoras. It goes back to Mesopotamia and so forth. Who published Simpson's rule? It says Simpson published Simpson's rule. Who originated the Taylor series? It says Taylor originated the Taylor series. So the Pythagorean theorem is, we don't really know when that was discovered. It's ancient. There isn't a lot of good evidence around the time of Pythagoras, but it certainly existed beforehand. Simpson's rule was Gregory, and Taylor's series was also Gregory. So my summary there is that ChatGPT has given the obvious incorrect answer to 5 out of 9 questions. There are a couple of others where it gives a slightly different flavor to the paper from 1996. One of the problems with history is that you don't know what the more recent scholarship might say on those topics. So without doing an awful lot of fact checking, it's hard to sort of get to the bottom of. But yeah, who discovered Cramer's rule? Cramer did. It gave that sort of answer 5 times out of 9. And this gets me to the sort of important point, I think, that the reason that I can spot these errors is because I know the topics, or I've read something that knows the topics. And then how did I develop that ability? Whether it's in mathematics, whether it's in history of mathematics, whether it's in anything else. Well, I didn't develop that ability by writing queries to AI. So I think it's very hard to know what's the good advice, I think. There was some discussion in the Q&A after the previous talk about, you can prompt it to do the right thing. You can get it to give you more elaborate, get you closer to the meaning and stuff like this. I think these tools will improve, and I think they are improving. And I do worry a lot about, if you can just put a query into a tool and it gives you the answer, then kind of what's the point in learning the stuff? And there must be a point to learning the stuff. And I think the other way round that I look at that is, if I already know the topic, then what's the point in asking the tool, unless it's for sort of summarizing and things like that. But if I don't know the topic and I'm asking it for new information that I don't know the answer to, well, I can't trust it, right? I don't know whether it's right or wrong. So kind of what's the point? And yeah, I find that sort of thing very troubling. It's very good at text processing. Actually, at this point in the talk I gave to students, I showed them that for one of the references in this talk, the journal website gave me a bunch of code, BibTeX code, and I just stuck that into ChatGPT and said, please write me an APA reference, and it did it. It's very good at stuff, right? It's very good at text processing. Um, it's also, I'm told, very good at summarizing. Um, now, I I can write fairly well. I think I can certainly, I'm all right at it. I quite like doing it, but I know that not everyone is like that. So there's a version of this where you say, please give me a summary of this topic, which I already know, but I don't know how to write it very nicely. And then once you've written it, then I can fact check it because that's absolutely fine. But my feeling is just that they are not trustworthy for reporting facts. And it worries me a lot, I think, that if students are going to use them as though they are trustworthy for reporting facts and not then develop that expertise, I think that's very hard to navigate, isn't it? Um, oh, and I put this in just because it amuses me. Um, my son and I read I, Robot, the Isaac Asimov collection of short stories, and he has one of these big artificial brains, which is sort of running the world so that humanity doesn't have to think about things too much. But in one of the stories, this is being developed, and he says the machine is only a tool after all, which can help humanity progress faster by taking some of the burden of calculation and interpretation off his back. The task of the human brain remains what it has always been, that of discovering new data to be analyzed and of devising new concepts to be tested. So it's that thing about that sort of higher level, deeper thinking, and it just amused me that Asimov has this in 1950, and yeah, that's what we should be doing rather than doing some of this automated stuff. But you just have to be able to trust what it's giving you back, I think. Anyway, that experiment I wrote up for the British Journal and for the History of Mathematics. So if you're interested, I'll leave that on the screen for a moment, and then if you want to take a picture of the QR code, you're very welcome to. But yeah, that's what I have to say. So I hope that was interesting.
Thank you, Peter. That was, and
Mm.
definitely round of applause there
Thank
for
you.
Peter. Um, and I think, Peter, what you sort of really highlighted was we can sort of tell the students or tell individuals of the problems that some of these tools have, but
Mm.
it's actually only when you start using them and you see some of the biases or the misconceptions, or well, it's not even misconceptions, some of the just wrong answers
Mm.
that come through. I think that's when it becomes really apparent. And something that we haven't yet got any questions in the chat, but something I'd like to just perhaps ask you about, if I may, is something you really touched upon, which were what I would call the essential, the graduate skills that we're trying to develop in mathematics students. And one of them is that ability to sort of validate, to recognize that things are incorrect, and there's an opportunity to use these tools to do that. But something I don't think we focused on enough is if students become reliant upon these, what might it mean for the essential mathematical skills? And
Mm.
I think that's something you've touched on. I just wondered whether you wanted the opportunity or felt able to say a little bit more.
Yeah, I just don't know where it's going. It's that's the problem, right? It's kind of there's a version of this where we just sort of stall because people are only able to query the tool, to get the previous knowledge, and then how are we getting the new knowledge, and how are we developing the new experts? And I do just think it's very problematic. And we're almost in a situation at the moment where the tools aren't brilliant, and then you can say, oh, well, don't use them for this and don't use them. But as they get better at this sort of very superficial thing, how are we going to get people to learn this new stuff? I just find it really difficult. Yeah.
It
Um,
is, and it almost becomes sort of cyclical, because there's
mm,
also the risk, isn't there, where you get those AI generated answers to those questions suddenly appearing on various sites, and they get refed into training again.
mm,
And then before you know it, there's sort of the balance of probabilities, there's more of those than the real answers.
yes.
And almost, I sort of wonder if there's this kind of, downward spiral going to come,
Mm.
because we won't know what content's real, what's AI trained, and it will just propagate. And
I've
so,
heard that theory that this is kind of the peak, actually,
yeah.
that these things aren't going to get better because they're going to keep eating the. I've forgotten. There's a phrase that people use. I've forgotten where it is, where you're sort of eating the garbage that's been produced by a previous iteration, and yeah.
Yeah, and sort of spewing it even further almost
Mm,
in, if we're going to mix a few metaphors. I'm
yeah.
going to pick up on a question here from
Mm,
Kieran McInverd, who said, "Loved your talk," and I think we all agree with that, Peter. That suggests that we should use AI results as part of assessment. E.g., AI provided the following answer on the origins of Gaussian elimination. What are your thoughts on that? Almost rather than sort of saying,
mm,
if you can't beat it, let's join it, and let's, rather than starting with the students crafting an answer from scratch, let's use
mm.
AI generated answers, and incorporate that into learning. Do you have any thoughts on that?
Yeah, I think that's a really interesting idea that you, yeah, please fact check this essentially. This is what the AI said. I'm not quite sure about it. Could you please investigate? And that will hopefully teach the students that skill of that critical thinking, first of all, but also those fact checking skills. How do you then go and investigate? Yeah. Actually, the person I was talking to earlier who said, oh, it turned out I was asking an AI rather than searching the web, she said it gave her an answer to her question. And she's like, but when I did search the web, I couldn't find that. So where did it come from? Like
Yeah,
it doesn't exist as an answer. It's just something that it's made up because it wants to say something to you. Yeah.
it is, and there's
Mm.
always the risk that it's going to get something right. By the
Mm.
balance of probability, it will come up with something that we didn't know,
Yeah.
and it will be
Yeah.
correct. Um,
Yeah.
do,
But
do you ever?
there's an assessment format that I've heard people talk about where you sort of say to the student, copy and paste the chat
Mm.
GPT into a Word document and then turn on track changes, and what you get marks for is what you've done after the fact. And I think again that's sort of, you could do that in a sort of fact checking way as well, couldn't you? That's potentially more worthwhile.
I'm going to put you on the spot one more time, Peter, and it
Sure.
follows on from a question Cecilia's got there, slightly modified. But given what you've said, do you think we would ever be able to train a chat bot, so the training phase, that
Mm.
would be able to deal with the history of mathematics in a successful way? Do you see that on the horizon, or do you think there'll always be that randomness coming through?
I mean, I honestly don't know, but I sort of imagine not. The other thing that I didn't talk about, which I do mention in the paper because it's for a history of maths journal, is that there is a lot more to history than just getting facts right. Right? There's a whole way of thinking, there's a whole way of investigating. And I think that again, there might be ways that AI tools in collaboration with a subject expert could help you with translating ancient languages or something like this. But it's so hard to see that it would be meaningfully able to engage as a historian would. I just don't think so. Mm.
Brilliant. Thanks, Peter. And if colleagues haven't found that paper yet, do follow it. I'm sure Peter will ping quickly back on the slide if you want to, Peter, with the QR code
Yeah, I can
to
do.
help people. But I think what it does is it gives that kind of a bit more insight into some of Peter's really given the highlights, but that's a really kind of nicely written, well argued paper that sort of sets out the ideas here. So it's definitely worth a read in the British Journal for the History of Maths if you haven't yet seen it, and it's pretty easy to find via Google. If that doesn't work, just stick it into
Mm.
ChatGPT and see what happens. Perhaps, who knows? And then email Peter and let him know. But Peter, thank you, and I think a big thank you to Lewis, Carol, Inga, and Peter again for a really quite superb session. I think this will not be the last time we have a generative AI session. It will be the last time this academic year, but we will be picking this up again. And I think our four speakers have really shown there's a lot more to explore here. And we really do appreciate them making the time to do it on this very sunny day. So thank you, everyone, who speakers, delegates, not just this session, but throughout the year. A big thank you as well to Kevin and Rachel, who make not only help spread the workload here, but make actually putting these Talmo programs together really quite a lot of fun, and we really do enjoy doing it. So please do, as we'll pop in the link for proposals again, please do share and encourage, because I think Talmo works because of the contributions from the community, and we are enormously grateful to you for that. So I think we've run over a little bit, but it's been worth it. A big thank you to our speakers again. A big thank you to all speakers on Talmo this year and everyone who's attended. And yes, videos will be available as they are on the YouTube channel. Not immediately. We have to be quite fair to Kevin. It's a bit too hot to be sitting in front of a computer today to do that. But we will be back in the new academic year. We look forward to seeing you all again. Thank you, everybody. Have a brilliant and well-earned summer. Let's hope the weather continues. Thank you, everyone.